Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's the problem for today for exam P on probability. A theme park conducts a study of families that visit the park during a year. The fraction of such families of size m is 8 minus m over 28, where m is equal to 1, 2, 3, 4, 5, 6, and 7. For a family of size m that visits the park, the number of members of the family that ride the roller coaster follows a discrete uniform distribution on the set 1 through m. Calculate the probability that a family visiting the park has exactly 6 members, given that exactly 5 members of the family ride the roller coaster. And here's the solution. So let us write m for the size of a family that visits the park, and it's a random variable, and let n be the number of members of the family that ride the roller coaster. That's a random variable again. And we want to calculate the probability that m is 6 given that n is 5. Now you can see that in the problem what is given is the probability distribution of n given big M value. It's uniform on the set of integers from 1 to m. And the question asks the conditional probability with the two random variables flipped. So we are given probability of n given m, and the question asks probability of m given n. And whenever you see this, it's a Bayes theorem problem. So we're supposed to just carefully use the Bayes theorem, and we do. So it's the probability that m is equal to 6 given that n is equal to 5. And you have to memorize the Bayes theorem, but it's pretty straightforward because what you have in the numerator is conditional probability with these two flipped, so probability that n is 5 given that m is 6, multiplied by the probability of the thing that is after the line, the vertical line, so what this is conditional on, so multiplied by probability that m is 6. That's the numerator. The denominator has the sum of all possible values of the random variable m, so the one that we conditional on in the numerator. Basically a sum of the same things, of all the possible things for what we have in the numerator, but for all possible values of m. So it's a sum from m equal 1 to 7 of the probability that n is 5 given that m is m times the probability that m is m. Again, this expression is exactly the same thing as the numerator, but we add up the sum over all possible values of m here. And we plug it in, and what we get is this is 1/6 times 2 over 28. That's straight from what is given in the problem. Divided by, well, and then we need to do the same for all these possible values, and that's 0 for the first 4, then it's 1/5 times 3 over 28, and again that's straight from what is given in the problem for the probability distribution of m, and the conditional probability distribution of n given m. So plus 1/6 times 2 over 28 plus 1/7 times 2 over 28. Okay? Well, then, of course, the zeros don't matter. And the top, we will make it into 1/6 times 2 by multiplying all of this by 28. But if we multiply all of this by 28, 28 will also disappear here. So we basically multiply the top and bottom by 28, and 28 disappears. It becomes 1/6 times 2 over 1/5 times 3 plus 1/6 times 2 plus 1/7 times 1. Well, okay, 1/6 times 2 is really 1/3. So what we have is 3/5 plus 1/3 plus 1/7. What is the common denominator of 5, 3, I'm sorry, common multiple, first common multiple, lowest common multiple of 3 times 5 times 7. If we multiply the top and the bottom by it, we'll get rid of all the fractions. So that's what we do. Multiply the top and bottom by 3 times 5 times 6. And this whole thing becomes 35 over 63 plus 35 plus 15. And then we just calculate it to be approximately 0.3097, which is answer E. Please remember this is copyrighted material. The problem itself comes from the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.